save money, right? Yeah, right. Yeah. 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 That's pretty high, actually, yeah. And that's a very controversial subject. And sometimes utilities will argue to their dying breath about what price they should pay you. Ah, right, right. So this way they can take some credit for it. Yeah. 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 Yeah, so it's interesting. I think there are good reasons to put panels up for sure. I have a twin brother who lives in Western North Carolina, and he's putting panels up. But for him, he's in a very rural area. It's more about, well, I want to get my system to be able to island so that if I'm affected by extreme weather, he's going to be the last person who gets their power restored. He's got a young kid. It's like, okay, well then there's a little resiliency there. But yeah, it's a very solar is such an interesting technology because individual people can adopt it, right? And for some utilities, that is kind of threatening, right? Like you could imagine that we no, but ask, yeah, like please. Yeah, it's very different. Like if you were building the grid today using the technologies that we have, I'm sure we would have way more rooftop solar. But given that we have high voltage transmission networks, right, that allow you to send electricity thousands of miles at the speed of light, it kind of diminishes the value. But if you think about other countries around the world that are trying to just get more energy access, and they don't have high voltage transmission systems, it's a no-brainer, right? It's like, okay, you start with, you get as much as you can with distributed solar first, and then you figure out what actual infrastructure on top of that. But you could imagine that, like, we'll get to a point where solar batteries are so cheap, they just come to your house, right? Or just like, it's like having a refrigerator, right? Yeah, I think we'll get there, right? Yeah, not that much. Yeah, yeah, yeah. I'll jump up on. Yeah.
Well, good afternoon, everyone. It's good to see you all here today. My name is John Mann, Director of Education for Lakeside, and today we're very fortunate to have Jordan Kern joining us for afternoon sessions Climate Change and What to Do About It. In this presentation, Kern will discuss how climate change is a complex challenge for many reasons. Its impacts are uncertain, but solving the problem requires action today. It requires global coordination, but the causes and effects are not equally distributed across countries. Kern is an assistant professor at North Carolina State University, where he has a primary appointment in the Department of Industrial and System Engineering and graduate facility in Operations Research in Civil Construction and Environmental Engineering. In 2022, Kern received the National Science Foundation's Early Career Award for his proposed title, Navigating a Two-Front Challenge for the Power Grid, Extreme Weather, and the Race to Decarbonization. I do ask you to please mute your cell phone ringers and help me in welcoming Jordan Kern.
Thanks for being here. Thanks for having me. Thanks to John and the Lakeside Environmental Program for inviting me. And yeah, I'm very happy to be here. I'll start with a little bit about me. I'm from North Carolina, and actually spent some time in Lakeside as a kid. My family was the guests of Phil and Betsy Savage, who are sort of like my godparents and have been long-term residents of Lakeside. I did all my education at the University of North Carolina, Chapel Hill, which is not by design, really just sort of a series of happy accidents. And then other than being a professor at NC State, I've spent some time as a contractor for the federal government as part of the Department of Energy Hydrogen Fuel Cells program, which at the time was kind of hooey and now is becoming a little more in vogue, and I'll talk a little bit more later on about the potential role of hydrogen in decarbonization. I'm married. My wife Alex is actually in the audience. She's an MD PhD at Duke University. We had 2 little kids. This is them when they were a lot smaller. Now they're 12. And they're here too in Lakeside. They're just running around today. So. All right. I guess the story of this particular lecture is that I teach a couple of different classes at NC State, and this lecture is sort of modeled after class number 1 for one of the courses that I teach, which is not an engineering course. It's sort of like a broad general education course about energy systems, climate change, everything in between. And so this is like what I deliver on day 1 of that course to try to spike some interest. So hopefully that works here. So we're going to start out talking about aliens. Does anybody know what the Drake equation is? Or has anybody heard of the Drake equation before? Yes. Okay. It is an equation, meaning there's an equal sign, and there's stuff on the left-hand side, and there's stuff on the right-hand side. So the history of this is that it was created by this guy named Frank Drake. And it was created at the world's first SETI meeting. SETI is S-E-T-I. It's the Search for Extraterrestrial Intelligence, which sounds kind of wacky. But this was 1961, right? So in the middle of the first space race, post-World War II, the idea that there could be extraterrestrial life and/or extraterrestrial intelligent life, including in our own solar system, was at the time a very serious scientific question. Now, for decades and decades, it's been sort of like tinfoil hat, but it's actually becoming a more rigorous scientific question again today. But anyway, in 1961, they had this meeting, and at the meeting, there were lots of actually scientific luminaries, including Carl Sagan, who's the author of Cosmos. He was the host of the original Cosmos television show, and just like a brilliant scientific communicator, in addition to being an astrobiologist. So they had all these famous scientists in a room trying to figure out the answer to this one question, which is, what is the number of active, communicable, meaning they would have to be somewhat intelligent aliens with access to technology on par with what we had at the time, which was radio telescopes. How many of those active, communicative, extraterrestrial civilizations are out there that we could communicate with if we're pinging them, if we're shooting signals out of radio telescopes? How many are out there that could conceivably receive our signal, right? And then within our lifetime, bounce a message back that was like, hi, or something like that. So that's what they tried to do here, right? They got out a big paper and pen, and they tried to deduce what this number could be. So they're trying to predict n, which is the value on the left-hand side of the equation. It's the number of alien civilizations that are out there in the Milky Way galaxy that we could talk to. So what goes into that, right? How do you determine what n is? And they thought about it in a pretty logical way, right? They started with r, which is the rate of star formation. How often are new stars created? And then they said, okay, well, if we know r, we have a guess about r, what fraction of those stars have planets, right? And now we know it's very, very high. What fraction of those planets could support life, right? So sometimes astrobiologists will use the term Goldilocks zone. You don't want to be a planet that's too close to a star, right? So you probably don't have an atmosphere and you can't support life. And you don't want to be a star or a planet that's too far away from, right, the star, because then it's too cold and you can't support life. So how many planets per star in the Goldilocks zone? What fraction of those planets do develop life, right? Any type of life. Single cell, multicellular, intelligent, anything in between. The fraction of that fraction that develops into intelligent life. The fraction of that fraction, right, that develops radio telescopes, right? So we're slicing it thinner and thinner and thinner. And then the last one is L, which is the length, meaning duration in time, of an intelligent civilization that develops radio telescopes. The reason why that matters, right, is because we would, in theory, be communicating with these aliens. I promise I'll get to climate change at some point. We would be communicating with these aliens over incredibly large distances, right, where even if we're sending signals via radio telescope, it could take years and years and years and years for our message, hello, to get there. Then they get it. Then they send it back to us, and it could be years and years and years for us to receive that message in response. So the point of the Drake meeting was to estimate the value of all the stuff on the right-hand side so that they could arrive at a guess for n. Right? And this is what they came up with, right? And some of these are kind of illuminating, right? For example, right? They think that 100% of all planets in the Goldilocks zone, right, will develop some sort of life eventually, right? Which is an optimistic view, potentially, on the formation of life on alien planets. And then 100% of those planets, right, that do develop life, given enough time, will develop into intelligent life, which is probably also an optimistic take. A much smaller fraction of those will develop into intelligent life that can use radio telescopes, etc. But the other thing that's illuminating about this is the degree of their uncertainty, right? If you look at all the things they were trying to estimate, right, they had a lot of precision, right, about their estimate of FL and FI, right? They thought, oh, it's 1, it's 100%. Even the other stuff that is uncertain, FP, right, ranges from 0.2 to 0.5, right, which is a pretty small range. What they were really deeply uncertain about was L. They thought that the duration of an intelligent civilization was either on the low end 1,000 years or on the high end 100 million years. That's a really big range, right? Especially if you're multiplying that number, which could be really small or really large, times all this other stuff to get in, right? So if you think L is really small, you get a very small n. So small that basically means we'll never communicate with aliens, right? If you assume L is really, really big, even if these other values are small, it ends up meaning, in their view, that it was sort of inevitable that at some point we would encounter, right, or be able to communicate with aliens. So for our purposes today, right, the interesting part of this is the uncertainty that they felt about the duration of an intelligent civilization. They thought, and Carl Sagan thought this, and this actually, when he realized this, became in some ways his moment where it spurred his interest in environmentalism. And, his thought was the major threat for humanity was a nuclear war, right? And he was, became a sort of a lifelong proponent of mitigating the risk of nuclear armed conflict. But he thought, and the rest of the SETI community thought, that L was either really small or large. And it doesn't mean that uniformly for all intelligent civilizations, right, they're all small or they're all large. But given a wide mix of different civilizations, some will have very small L values and some will have incredibly large L values. So what does that mean? Any ideas? What does that imply about the stability of intelligent, technologically advanced civilization? It is a crapshoot, right? So, and it's potentially a little incriminating, right, about the stability of intelligent civilizations. The idea was that once you develop the ability to communicate with other planets, right, you are advanced, right, technologically to the point where you have the capability to blow yourself up one way or the other. That doesn't have to be by a nuclear war or whatever. It could be through something like climate change, right, or inadvertently, creating other risks. Or you've developed technologically to the point where any challenge that you encounter, you'll be able to solve, right? And basically, you're on this pathway towards, as a species, right, immortality, right, collectively, right? You could colonize other planets, and the more you colonize other planets, the lower the likelihood is that any one of those planets wipes you out as a species, right? You start colonizing your solar system, other solar systems, and then humans live forever, or aliens in this case. Okay, so now to climate change, right? And this is a question that I ask undergraduate students on the first day, which is, do you feel like climate change, anthropogenic climate change, meaning humans putting greenhouse gases into the atmosphere, triggering a whole series of physical changes to the Earth's climate, do you feel like that poses an existential risk to humanity? And I'll be even more specific. Do you think it's something that would prohibit our being able to communicate with alien civilizations sometime in the next 100 to 500 years? So raise your hand if you view it as an existential risk in that regard. So a handful of people, right? And now raise your hand if you don't view it as that level of risk, but it's risky, worth worrying about, something like that. Yeah. Good. So I will say, I feel like undergraduates come in and on the first day, their hands all shoot up, right? And I think a lot of it has to do with learning about climate change as this scary thing that's very uncertain, that doesn't have any real clear solutions, or it does, but it doesn't look like we're implementing those solutions quickly enough. And so a lot of what undergraduates come in with is a sort of a history in the K through 12 educational system of being told the world is doomed, right? And so it's understandable that their hands shoot up really quickly. And I don't really try to change their mind about that other than to just provide some nuance, which is what I'll try to do today. Okay, so here's my take. Oof, that's bright. The y-axis is greenhouse gas emissions, more or less, right? So carbon dioxide is only one type of greenhouse gas. So this is measuring, and the black solid line at the beginning, right, is history. It's what we've observed to happen. So we're measuring how much CO2 could go into the atmosphere on the y-axis, the up and down vertical axis, and then time out to 2100 on the x-axis horizontally. So this is what could happen if there were absolutely no efforts made to mitigate climate change, right? We just sort of acknowledge that the problem exists and then sort of willfully ignore it, right? And so there's uncertainty, right? There's uncertainty about how much CO2 or greenhouse gases we would in fact emit over that time period. But without any action, right, it would lead to an estimated average global air temperature increase of between 4 and 5 degrees, right? Most climate scientists would agree that that degree of warming, right, unmitigated, warming, with no policies in effect, would result in a series of catastrophic changes, right, for people and the planet, most of which are sort of initially triggered by air temperature increases or global warming, right? So exposure to extreme heat is by itself a risk, but it also causes sea level rise, increased storm severity, not necessarily stronger, higher wind speed hurricanes, but certainly higher precipitation events, i.e. when it rains, it pours, because hotter air holds more water. Changes in water availability potentially, so more water in some places, less water in other places, decreases in food productivity, increases in infectious disease because of higher air temperatures. Certain vector-borne diseases can spread more widely. Species die-offs, mass migrations of people, right? If there are certain parts of the planet that become inhabitable, people will try to get out of those and maybe go to countries next door that don't want them there. And then increased conflict, right? So for years and years and years, the U.S. Department of Defense was one of the most progressive organizations of the federal government around climate change because they viewed it as a threat multiplier, right, across the world. Okay, so the answer to number one, right, is if left completely unchecked, right, I think most scientists at this point feel like it would be profoundly destabilizing by 2100, right? I don't know if that means we won't be able to talk to aliens or our radio telescopes won't work or we won't have the funding to build them or whatever, right? But it would be potentially a very unpleasant place to live, right, by 2100. So second question, was it inevitable? And I think this is an important one, especially for undergrads, right, 20-year-olds who are potentially having to deal with this problem, to try to understand in some ways the ethics and morality around climate change as an issue, which we're going to talk about some today. So was it inevitable? I would argue that yes, some degree of climate change was inevitable and it was tied inextricably to the desire of humans to lift themselves out of abject poverty, right? So this is across different parts of the United States, tracking income per capita, right? And not the distribution of income, which is skewed, right? But on average, how wealthy people are across different parts of the world. And you can see that in the latter part of the 19th century, right, it starts to explode, right? And this is almost entirely to do with our use of energy and irrigated agriculture and things like that. And today, right, our contribution to climate change in the form of emissions of greenhouse gases are also inextricably linked to everything that, goes into modern life, right? Food production, heating and cooling your homes or businesses, growing food, right? Getting from one place to the other via transportation and building stuff, right? Everything that we do, right, entails some emissions of greenhouse gases, more or less, right, as of today. So it does feel like it was sort of inevitable, right? And we could there's a history of the science of climate change and the policy of climate change that feels like sort of shouting into the void, right? Where people in the 70s, 80s, were broadly aware of the potential for a greenhouse gas effect. But the amount of time we're talking about between when there was scientific consensus about climate change and the ability technologically to do something about it, we're talking about 20 years, right? Which is a pretty short period of time to decide, well, we need to radically rethink how we get the energy to do all this stuff that we really care about, right? And feel like we need. So it does feel a little inevitable. Now, can we solve it? And what does that mean? All right, so let's start here, right? So this is not solving it, right? This is choosing to not solve it, right? Implementing no policies to address it in any way. Is this where we are today? No, we're actually way better off than this, right? So the current trajectory where we're on, now these are, all the colors are futures that have not happened, right? They're projections about what could happen in the future. But given all the current policies worldwide that have been implemented over the last 10 to 20 or longer years ago to try to address climate change and greenhouse gas emissions from all those different economic sectors, we're now somewhere on this orange path, right? And the world collectively does have the framework of an agreement in place to try to manage climate change called the Paris. It was an agreement that was ratified in Paris by most countries around the world. And that's not a binding rule. Everybody's just sort of volunteering to do the right thing, or I shouldn't say do the right thing, but to reduce emissions. And collectively, all of those get you to this blue line, right? Which would result in an average air temperature increase by 2100 of about 2.1 degrees, right? Now, what most scientists would say it would look like success in terms of dealing with climate change would be to be way down here, 1.5 degrees, right? So we're not in no man's land, right, way up there, but we're not at this ideal goal of 1.5 degrees Celsius, right? Now, the target of 1.5 degrees Celsius is the output of lots and lots and lots of global climate change modeling where you have your computer simulation of how much CO2 you put in the atmosphere, and then you see what happens, right? You see how high the temperatures increase, how much sea ice melting there is, et cetera, et cetera. So the consensus is this is the safest path for us, is to get to 1.5 degrees Celsius. That means that emissions of greenhouse gases worldwide basically have to peak today, decline to net zero by 2060, which doesn't mean we can't put anything up into the atmosphere, but if we put any into the atmosphere, we got to be simultaneously sucking it out of the atmosphere, either through increased vegetation or other types of direct air capture. And the way we do this, the sort of consensus at this point, is to try to electrify as many pieces of this pie as we possibly can and make sure that the electricity that we do produce is coming from zero emission sources, which could be nuclear, hydropower, geothermal, wind, solar, other stuff that hasn't been invented. It probably means we need to, especially in other countries, right, manage deforestation. And agriculture, especially soil management, can create emissions of different types of greenhouse gases. And then also the meat industry, unfortunately, is a major source of greenhouse gas emissions. And so seriously tackling climate change likely means that humanity would have to consume less meat. So there's all these different ways we could do this, right? And there's the number of technical challenges that at this point feel insurmountable is getting closer and closer to zero, right? Meaning we're not waiting on something that would unlock our potential to do this. We basically have all the technologies we need to have today. The problem is that in some cases they're kind of expensive, right? And we'll talk a little bit more about that. So just in the US, right, how much would it cost to meet this goal, right? To get to net zero carbon emissions by 2060? The estimate is that it would cost about $30 trillion, which is roughly 1.2 to 1.5 GDPs, gross domestic products, right? So a way that economists measure the economic activity of countries, right, or other political units. Just to put that in perspective, World War II cost us 1.8, right? So often when people, are talking about the challenge of dealing with climate change, they will reach back and use this historical perspective. They'll say, well, we've done big things before. This, World War II was a moral, ethical, security imperative, all of which we would probably all say the same thing about dealing with climate change, and we did that, right? So we can do this too. Now, that's expensive. That's a lot of money to spend, right, dealing with the problem. And it's a very specific type of problem that in some cases makes it difficult to decide to spend that degree of money on it. And we'll talk a little bit more about that as well. So the last question is, will we deal with climate change? Will we solve it? Will we reach 1.5 degrees Celsius or something like that? We know how to solve it, more or less, what technologies we would employ in what different sectors to do this, and we know roughly how much it could cost. And then the more difficult question is, will we decide to pay that cost, right? And I think then it's worth talking about all the different ways in which climate change is a very thorny, complicated issue, even among other societal and environmental issues. So I have my list of reasons why I think climate change is difficult to solve. And often at the beginning of this, I would ask undergrads to talk about it. And, people would raise their hands and say, broken politics, corporate greed, stuff like that, which is going to play some part in this, but it's a little more nuanced. The first is, I think it's important to distinguish the nature of the climate change problem from other types of environmental problems, right? So, the sort of classic environmental success story, right, is the Clean Air and Clean Water Act in the United States, right? Both of which were passed, I think, in the 70s, and targeted point source pollution, right? Pollution that's emitted in a certain place and predominantly affects the people living in that place, whether that's air quality or water quality. And the Cuyahoga River in Ohio famously caught on fire in the late 1960s, and this was a big driver of the environmental movement in the United States and the initiation of the Environmental Protection Administration and the passage of environmental laws. And I think when you think about clean air and clean water, which are the two main ways that people experience environmental quality or lack thereof, right? Those have both been unmitigated successes in the United States. The air is, for the most part, cleaner than it's been since, the 1960s. Same thing with water, right? With the exception of nutrients, which is a different problem. Climate change is different than this, right? Like there are thresholds and tipping points beyond which we could push the Earth's climate to the degree that we can't recover it, right? Like we can't clean it up like a lake. We can't clean it up like, an atmosphere. And most of these have to do with loss of ice, honestly, right? So ice is white, right? It reflects sunlight. The less ice you have, the less sunlight you're reflecting. So this is a process where even if you slow down emissions of greenhouse gases globally, you could still end up with accelerating climate change, right, if you push it past a certain point. And that's a really difficult problem to solve, right? It makes it, that's the emergency part of the climate emergency, is like we are inching closer to a point where even if we get new technologies, right, or find political will to solve the problem, it could be too late, right, which is unlike other types of environmental issues. Okay, so number two, one of the main reasons climate change is difficult to solve is that we have to do something now in order to get benefits way off into the future, right? And that is also unlike most environmental problems, right? And so, you know, going with the analogy of World War II, right? We can do big things, right? That cost a lot of money, but we did it. I think there is probably a lack of a single salient event that will motivate people to decide, oh, this is worth spending a lot of money on, right? And it's not like we haven't had any chances, right? So this time last year, if you were in Lakeside, you probably experienced something similar to this, right? This is looking across, I believe, the Hudson River at Lower Manhattan on June 23rd, right? And this was caused by unprecedented wildfires in Canada, right? And so I remember reading like, boy, people were like, this is it. People are gonna start taking climate change more seriously. It's more complicated than that, right? So that's part of the issue, right? Is that unless it hits you right at your doorstep consistently for a long time, it's hard for people to really be motivated by this. The other is this, I would say, probably innate part of human psychology, right? Where we tend to value the present more than the future, right? So let's say somebody you really trust comes up to you on the street and they say, I will give you, it's your birthday or something, you know, maybe not birthday, it's a special occasion, you won some sort of prize, and they say, I'll give you $1,000 right here. Or I will meet you back here 1 year from now and give you some other amount of money, right? Now think about how much money you would accept 1 year from now in order to forego accepting $1,000 today, right? Ideally, it would be a larger number, right? Because you'd rather have $1,000 today than $1,000 a year from now, right? But the question is, would you accept $1,000 plus 5 to wait 1 year, right? And this is a very funny question to ask 20-year-olds because they can think of lots of good things they could do with $1,000 on Friday and Saturday nights. So, but think about what your answer might be, how much you would be willing to accept 1 year from now in order to delay gratification, right? And then think about, well, how would your answer change if you were younger or poor, or you were raised in a different family or from a different country, right? So if we think about, and this isn't just, it's a sort of like grossly simplifying this, but if you think about who values the present more versus the future more, or who values the present more and the future less, it would be somebody that says, I will take $1,000 now unless you give me a lot more money 1 year from now, because I have bigger fish to fry. Right now, I could really use that $1,000, right? Maybe it's for something fun, or maybe it's for something that you really need. And all humans discount the future relative to the present. We all inherently value the present more than the future, right? But we all do it to different degrees, right? If you asked everybody in this room, everybody would have a slightly different answer, right? And a slightly different reason for giving that answer. And it makes evolutionary sense that we are to some degree, more heavily invested in the present than the future, right? There's not really selective pressure put on humans to think about what's going to happen multiple generations in the future. We want to pass genes on one generation, right? That's what's selected for. And the problem is that that characteristic makes it difficult for us as human beings, especially collectively, given that we all have a different sort of psychology around this, to decide how much is it worth sacrificing today for the future, right? And that means that you can both believe climate change is real, believe that it poses a serious threat, and not be willing to sacrifice too much to deal with it today. And it doesn't mean that that's a immoral decision, right? It means that that's your lot, right? You have to balance what you owe yourself today and the people around you today versus what you owe people in the future, right? Okay, number 3, the reason why this is difficult to solve is that emission sources and climate change impacts are not evenly distributed. When we talk about who's responsible for climate change, it's the countries that are dark here. When we think about the countries who are not necessarily responsible, it's the countries that are lighter colors here. And as you can imagine, this comes up, right, when the United States is negotiating things like the Paris Agreement, where they're trying to figure out how to convince everybody to reduce emissions. You could imagine when John Kerry or whoever the special envoy for climate is to the UN goes to other countries and says, we think you should reduce your emissions, right? The first thing that they say is, why don't you reduce your emissions, right? I mean, historically, the United States has been the largest. Today is China, right? But historically, the United States is the largest contributor of greenhouse gas emissions. And the places that emit the most are not necessarily the places that would be most profoundly impacted by climate change, right? But certainly the places that emit the most, if you view that as sort of a proxy for economic development or the sophistication of infrastructure, we are probably the most capable in the United States of adapting to climate change, and other countries may not have those same capabilities. So these dots are just places on coastlines that have cities with more than 1 million people. So these would be places that you would expect to observe some migration as a result of sea level change. Okay, the other reason why this is difficult is because it's uncertain, right? Everything that we've talked about today is accurate, but, right, when you bore into the details about the timing and the specific magnitude of how climate change will affect us across the globe, it's very uncertain. And this makes it very, very difficult for politics, right? Because a lot of, I have sort of a perhaps less cynical view about politics in the United States than is reasonable. I tend to view most politicians as wanting to actually do the right thing. But the reality is politics is very transactional, right? It's a lot of what will you do for me, right? What can I get for my electorate, right? Then I can go home and deliver and, be reelected in November, right? And so that makes it difficult because often it's, and even for like evaluating government programs, right? There's often economic scoring that has to happen. If the federal government wants to spend, $1 billion on something, right? They have to demonstrate that there's adequate return on investment, right? Often, right? For implementing those types of programs. And climate change doesn't really work like that. We are somewhat subject to uncertainty in our projections. So this is kind of similar to what I showed earlier, right? So on the y-axis up and down is measuring temperature increases. And on the x-axis horizontally are different years out into the future. And the range of colors, right, or the range from the top of the green to the bottom of the green here shows you how uncertain our estimates about temperature increases related to climate change are. And the the fact that there's three colors means there's three sources of uncertainty. The largest is the green, right? Because we don't know exactly what the green represents is how much CO2 we're actually going to put in the atmosphere, right? Because we don't know how much CO2 we're actually going to put into the atmosphere, we can't, it makes it difficult to forecast exactly how climate change will impact us. If we knew that, right, then the green would go away, but we'd still be left with the blue and the orange. The reason why the blue, right, is this sort of widespread is because scientists use like 15 different computer models to simulate the Earth's climate, and they all give you a slightly different answer, right? And then the orange is just internal variability, which means that for any given climate, right, we are going to experience year-to-year changes due to normal weather. But this makes it difficult for politicians to answer like really basic questions, which is, for example, like how much CO2 should we take out of the atmosphere to experience a 1-degree decrease in temperature? No scientist can answer that with precision, right? They can give the politician a best guess, but if you're being interrogated as part of a congressional hearing, politicians really don't like to hear, oh, it depends, oh, it's uncertain, especially when we're talking about potentially investing $30 trillion. And then, I think this is the last one. The last reason why I think climate change is difficult to solve is kind of related to all of this, right? All the other points that we raised before, which is that a lot of our economic decision-making and institutions are set up to move kind of slowly, right? Especially when it comes to building things and financing things, getting the money to build stuff. And they're not necessarily set up to move quickly. And one example that I sometimes give is sort of like the financial life cycle of like a power plant, right? So imagine we're not 100% ready to just do all renewable energy now, right? We need maybe some fossil fuels like a natural gas power plant. Many utilities across the country are building wind and solar, and they're also building natural gas power plants because they have an important role to play in sort of balancing out the intermittency of wind and solar. So let's say it costs $750 million, which is probably a dramatic underestimate, actually, maybe by 50%. And just like they would, if this is an electric utility, just like you would borrow money potentially to build a house or to buy a car, they also have to finance this, right? And most of the money that's raised is being issued through corporate bonds, right? They're selling bonds in order to raise the money to build this power plant. They have to pay interest on the money that they borrow, and they have to pay that money back gradually over decades, right? So if a utility builds a power plant today, and then 15 years later, they decide, we can't use this power plant anymore, right? Or maybe a government decides that they can't use this power plant anymore because it's polluting too much or producing too much carbon dioxide. It sort of interrupts the life cycle of this power plant. They might have to turn the power plant off. Even 15 years into the lifetime of this power plant, they might owe still $250 million, right? And that money has to come from somewhere. Would come from us for the most part, right? And so, utility, just in general, abandoning fossil fuel infrastructure that has been built under the presumption that it would be used to pay off the debt incurred as a result of the original construction could impose an extra cost on the companies, right? But what's much, much more likely is that they pass those costs on to consumers, right? So even if wind and solar is really, really, really cheap, that analogy sometimes that I give is like, let's say Tesla or whoever, right, puts out a flying electric car that costs half as much as a Honda Civic, right? But you borrowed money to buy your Honda Civic last week, right? Number one, you're not going to find anyone anymore that would ever buy your used Honda Civic, so you're stuck with it, and you borrowed the money to build it. So you can't buy Elon Musk's flying electric whatever, right? Or you could, but you still owe the money to the dealership or whoever lent you the money to buy the Civic, right? That's a bad example, but it does put this sort of like financial inertia on how quickly things can change, right? Or how quickly things can change painlessly. And also, by the way, it matters a ton where the money comes from, right? If the money that's raised to do this is coming through taxes, that's very different than if it's coming from increased prices on consumer products, right? Because taxes are progressive, meaning there's at least an attempt to get wealthier people to pay more than poorer people, right? But consumer prices affect everybody equally, right? And so the policies about where we get the money to do this has very important implications for how much burden is put on people that already have a hard time paying the bills. All right, so will we? I say fingers crossed, and not to be glib, right? But there's progress that's being made, and there's a lot that we can't control, right? Even within the U.S., but certainly outside of the U.S. So it's like anything, you do the best you can, cross your fingers. So just sort of like some recent stuff. All of this, I think, is like broadly true, right? But these are recent things that have come up really within the last, I would say, 18 months to 3 years that look like they're going to be a bigger deal over the next couple of years. So it's stuff to keep an eye on, maybe. One piece of bad news, I would say, is that the actual climate science community has sort of repeatedly learned that their models are too conservative, right? So the degree of warming that we should expect is probably higher than what they've been forecasting for a while. And some of that is an honest mistake, right? For example, what we've learned is that air quality standards, right, that try to reduce health effects for humans from like breathing in stuff like fine particulate matter, which is directly harmful for human health. Efforts to reduce emissions of those types of aerosols have actually warmed the planet, right? Because having little fine particles in the atmosphere, even though it's bad to breathe them in, actually cools us down a little bit, right? So we cleaned up the air a little bit and we heated up the planet by accident at the same time. So it's stuff like that. Good news though, right? It's becoming really commonplace for states across the U.S. to implement very aggressive targets for reducing greenhouse gas emissions. I would say, despite my optimism about individual politicians, the federal government as a whole kind of doesn't have a climate policy other than they just give money away, right? So the federal government has given away a lot of money in the last couple of years as part of the oddly termed Inflation Reduction Act, right, to incentivize uptake of renewable energy and other clean technologies. So the federal government has moved away from this idea that you should penalize people who are polluting and more towards, we will give you money to implement stuff that's clean. But other stuff that looks like it's going to be difficult to get a handle on. There's aspect, when I said that the technologies we have are there, right? And it's a matter of implementing them. One of the most critical things we can do, and the hardest things we can do, is build new high voltage transmissions. Nobody wants to live near high voltage transmission. And often what we're talking about is connecting parts of the country that are low population density but have a lot of resources like wind and solar to urban areas, and that involves building very large construction projects across straight lines, which is difficult, sometimes across private property, which is difficult as well. And then critical material and manufacturing supply chains. I would say there is bipartisan consensus that relying too much on other countries for rare metals and certain key components for electric power systems is a security risk, especially China. And so that's an issue, right? And also potentially it may be the view of the federal government that we should protect some domestic industry. For example, right? Let's say China can produce electric vehicles for half as much as we can in the United States. Then the question is, should we put tariffs on electric vehicles from China to try to protect domestic automotive manufacturing in the United States? And this is also true for solar panels and all sorts of other types of grid components. So this is becoming an increasingly thorny global political issue. And then the other issue is electricity demand is surging, right? Part of that's due to weather, part of it's due to electrification, right? So using EVs, using heat pumps instead of natural gas or oil heating, and all sorts of other stuff that's happening. And it'll be really interesting to see, now utilities, as you can imagine, love this, right? But it does require them to build more infrastructure, and we're gonna have to adjust the way we view infrastructure building in the United States. We're moving into a period where we're gonna have to build a lot quickly, and we haven't done that for a while, and so it'll be really interesting to see what happens. So I think I talked way too long, and I'm happy to take any questions or talk about anything else y'all want to. Thanks for having me. Did you have a question? Yeah.
Thank you for your presentation.
Sure.
I've read where there's kind of a moral, ethical question. There are many countries in the world that have not reached our level of standard of living.
Yeah.
Many, many. And now we're going to say, are we going to say to them, well, sorry, you can't come up to our level now because it's too much pollution.
Right.
You know? That's a moral question, really, in my opinion. Or do we let them come up and then say, okay, now you can have to go back down?
Yeah, that's right. There was this, for a long time, this idea in the environmental economics field that all countries go through the same trajectory, right? Where if you're a poor country and you're less developed, you have a higher discount rate, right? So you discount the future more than the present. You really care about the present, and so you're willing to pollute or spend down your supply of natural resources in order to gain wealth, right? And you basically gain wealth as a function of environmental degradation until you reach some point, right? And then your basic needs are met, right? From an infrastructure and institutional perspective, and people can afford to look a little further out into the future. And as they do that, and they look around and say, well, we got to start polluting less and come up with ways to maintain a high standard of living or even gain wealth, but to do so without damaging the environment. And that has largely been debunked, right? I mean, countries do develop, right, economically, and at least historically, some of that has been as a function of, pollution. But the idea that, like, in the United States, we've, I talked about the Clean Air Act and the Clean Water Act, right? And, at least domestically in the United States, air has gotten cleaner, water's gotten cleaner. But at the same time, simultaneously, we've been outsourcing manufacturing into countries that have much weaker environmental laws. So are we really getting cleaner, or are we just buying products from other places, right? So it is a very, very tricky dilemma. And I think it's something that negotiators wrestle with all the time, right? The idea that countries that are trying to increase access to energy, right, or decrease what they would sometimes call energy poverty, right, should be given allowances, right, to pollute, and that countries that have historically been polluting more or more technologically advanced should take more of the burden in terms of reducing pollution. But as you could imagine, is sometimes a, what do they call it? American exceptionalism, right? So it's like, it's not, you know, like when you're negotiating and you're part of the U.S. government, the goal of the State Department, what is it, what they say, the art of diplomacy is letting other people have what you want, or something like, or have your way, right? So a lot of it's geared towards protecting American interests, right? And so I don't know how much of that comes into play. And you know, I think that's, if you think about other potential administrations, like Republican administrations that may come in, that's the thing, right? It's the, like we are not going to allow other countries to emit more than the standards we hold ourselves to. And maybe there's some logical consistency there, but it does seem problematic. Yeah.
Think of the telephone industry. We strung miles and miles and miles and miles of wire to connect telephones. Everybody in China now has cell phones with no wires. I mean, there are leaps in technology. For electricity, solar is probably better in all these countries than what we've done with coal-fired power plants. So there are now technology jumps that will let them greatly improve a living condition without pollution. Electric cars are probably going to get there sometime.
Yeah, that's a great point, right? So, when you think about decreasing energy poverty, or countries that have historically been less developed wanting to simultaneously increase their access to energy while mitigating potential impacts on the environment, distributed solar, right? So small solar panels that are not hooked up to a big interconnected high voltage power system is a no-brainer, right? Especially if you have places that are rural, right? And sunny, right? So really we're talking about sub-Saharan Africa, right? And other equatorial regions. Right. And so that is one of the sort of like truly positive, there are basically no drawbacks, advances that have been made is the decreasing cost of solar, right? The place to, I guess, make a distinction is when you're talking about the United States. That doesn't necessarily mean that the right thing for us to do is to have a lot of distributed solar, right? It can be helpful, right? But if you have access to a big high voltage transmission system where you can send electricity from Ohio to North Carolina at the speed of light, right? It doesn't work quite that way, but it's close. Then that is a technological capability that you should take advantage of, right? So you have to be a little more strategic about how much you use solar here on people's roofs versus building gigantic solar farms in the middle of, you know, marginal value agricultural land, which is generally the way we're doing it in the United States, with the exception of basically California. So that's a great point.
So I love maps, and I love your map there.
Oh, good, yeah.
So I see the United States and the color there, and China is even a little darker.
It is, yeah.
And India is just a tad lighter.
Yep.
So what makes China so much a polluter, even more than the United States? And what are those things that create that CO2 emission? What are all the things?
Mostly coal plants, cement production, other types of heavy industry. That's right.
Okay,
Yeah.
right.
Yeah. They also have more renewable energy than the United States. It's a big country, they have more of everything than we do, right? Yeah, they're deploying renewable energy faster than we are per capita, but they also are building a lot of coal-fired power plants. And that's part of an effort to increase energy access, domestic economic productivity. China's thing is stability, right? They value stability internally, let's say, basically above all else. And they view increased economic productivity and access to energy, as we generally do as well, as the key to that.
And they probably now have more hydro than we have. They certainly have more solar
Yeah.
than we have.
Yeah.
So they're getting better faster than we are in some ways.
One point about solar.
Yeah.
I have a nephew who lives in rural Chillicothe. He's very smart, and he installed solar at his house, panels, I think, on the roof of some building.
Yeah.
He actually made his teenage kids get up there on the
Good.
roof and install
Good,
them.
yeah.
But he is now at a point where his energy consumption is powered by the solar in Chillicothe, Ohio,
Yeah.
which doesn't have too many more sunny days than we do. So,
Yeah.
Have that here.
Please help me explain eating less meat because I'm not going to give up my meat. I'm sorry.
It's okay, I guess.
So why is meat such an issue?
Yeah, so it's at like per gram of protein, it involves much larger emissions of carbon dioxide because of all the processes that bring feed to the animals themselves, right? So you're factoring in all the energy usage in growing alfalfa and corn and stuff like that, and delivering it to where the animals are. And then there's enteric, it's like the guts of, cows especially are the main culprit, right? They burp a lot, and they're burping greenhouse gases directly, and then the processing as well, right? So when animals go from animals to your shelf, yeah. No difference almost, yeah. The reason to do organic would be to avoid human exposure to pesticides, basically. But yeah, we've discovered that probably the most energy efficient way to raise cattle is to cram them into like tiny little feedlots, right? But there's then a trade-off between all sorts of stuff, right? Yeah. Yeah, so cattle is, in terms of greenhouse gas emissions, cows are the worst, and I think it's pigs, chickens. Yeah. Yeah.
That makes methane,
Right.
which in 100 years is 25 times as bad as carbon dioxide.
Yeah, it's, when I think about I showed that, you could think about which of these are the lowest hanging fruit, right? What are the easiest steps for us to take? And what are the hardest, most difficult steps? I would say convincing folks to eat less meat is among the most difficult things you could possibly get people to do. And there's all this cultural meaning behind meat. It's built into a lot of traditions we have. It's a different way than fake meat and vegetables, right? It's just like a different eating experience. Nobody cares where their electricity comes from as long as you go over to the wall and you flip a switch and it's there and you're not paying too much for it, right? But meat is, in diet in general, is a very personal thing. And so I know there's folks that are working on this, right? So like a group that I'm included with at NC State was just given $30 million by Jeff Bezos, right, to try to figure out, can we synthesize alternative proteins? That could be like lab cultured meat that's not really coming from animals, or maybe it's a plant-based protein or fermented protein. And it's there are options that are out there, but they just, for many people, are not that palatable. But that's I don't have that much optimism we're going to collectively, globally eat a ton less meat. All the rest of the stuff I feel more optimistic about. Yeah, thank you. Yeah.
Okay, now there's another, what I consider a moral question.
Yeah.
There are already islands in various oceans that are almost underwater.
Yeah.
And they will, you may know how many years, they will have to be evacuated.
Yeah.
They will have to be displaced, and a lot of countries don't like to take immigrants.
Yeah.
No, it's not funny.
No.
Because these people will have to go someplace and be assimilated, and we can't keep, the same countries can't keep taking the same number of people.
Right.
It's got to be spread out, and that's not going to be easy either. I think that's as bad a question as meat.
Yeah, I won't even begin to try to answer that one, although there are lots of like famous examples of countries that are right next to each other, don't like each other, and one's going to be probably profoundly impacted by sea level rise, and there's one place where those folks could probably go. So yeah, I think that's one of the big reasons why the government has been focused on climate change as a potential threat multiplier, right? Yeah.
Yeah, immigration, climate-driven immigration, we're already seeing in this country. There are 3 Central American countries where sustainable farming is becoming very difficult or impossible, and those people are fleeing north.
Yeah.
Bangladesh is going to have a huge...
That's the one that's...
that's the frightening one because of the number of people.
Yeah.
And they're going to go north. You get to mountains, it doesn't work.
Yeah.
So it's coming. And it's going to be ugly, and no country is ready for it. But it's going to happen.
You may be going to talk about this tomorrow, but can you speak to the use of agricultural land for the production of corn ethanol?
So I think it's really, really unlikely that liquid biofuels are going to be a majority or even a significant force of decarbonizing transportation. Like light-duty vehicles are going to be electrified. Like it's going to happen. Like major automotive manufacturers have already said, we're not producing internal combustion engine cars past a certain point, right? So to the extent, corn-based ethanol in the United States is, as a fuel additive, is really driven by policy, right? Where conventional gasoline producers are required to blend in a certain amount of corn-based ethanol, or ethanol, could be from other, but I guess corn is the cheap way to do it. I think that there's evidence that that has really not had a benefit in terms of reducing greenhouse gas emissions, and probably has had other major environmental impacts. I mentioned, so when I was talking about water quality is improving in the United States, the exception to that is nutrients, right? So eutrophication driven by excess fertilizer going into freshwater systems. Corn is a big culprit, right? And irrigated agriculture is a big culprit. There are other types of feedstocks that you could use to create liquid biofuels that are probably more sustainable, meaning have a lower greenhouse gas footprint and potentially a lower impact in terms of eutrophication, but they're more costly, right? And so the real question with transportation is how to decarbonize larger forms of transportation like air travel, cargo shipping, stuff like that. And it's unclear how we're going to do that. But the federal government is investing a lot of research, money in research for sustainable aviation fuel and shipping and things like that. And we'll see. But one thing I'll say is if you get 98% of this, or 95% of this, or 80% of this, that's great, right? 100% of this is maybe a little overly insistent on eating the whole pie, right? Like any progress is good progress. So I think if the easiest thing to do is just to electrify all light duty vehicles, and then we're still using conventional jet fuel for airplanes, that's not ideal, but it's better than what we're doing now.
I'm guilty of flying back and forth across the country all too much.
Yeah.
And I wish there was an alternative. For sure,
Yeah.
Our train system in this country is just abysmal.
Yeah.
But in flying over vast areas of this country, from here to Seattle and back and forth, it's hard to ignore the fact that there are circles all over the country. And the farther west you go, the more irrigation circles you see. And an awful lot of that is producing corn that ultimately is used in ethanol. And from some of the things I've read, one of the other big issues we have coming is in the depletion of the aquifers in the central part of the United States. In fact, even land masses are beginning to subside as a result of that. Would you like to speak to that a little bit?
Yeah, so that is, I would say, an institutional failure, right? Like if you don't have any, I'm gonna sound like a libertarian, which I'm not, but like property rights regarding groundwater consumption, right? Like surface water, like the Western United States, for as dry as it is, right, has very sophisticated market-based procedures backed up by a legal system of property rights, surrounding the access to surface water that allows them to sort of efficiently allocate what is a very scarce resource to the highest value needs, right? So like if you're an alfalfa farmer and you have senior water rights on the Colorado River or someplace in California, and you can use that water to grow alfalfa and send it to a livestock farm, or you could sell your water rights to LA and they'd pay 3 times as much, or an almond farmer or something like that. There's a procedure for transferring water rights to the highest economic value, right? That does not exist with groundwater, and part of that's because groundwater is this sort of classical common pool resource where there's no incentive for preserving it. Because if you and I are both on the same aquifer, right, you're gonna pump groundwater. All that does is make it less available for me in the future. So it's in my financial interest to also pump groundwater. It becomes this race between the two of us. So there are efforts, especially in places that, like this California Central Valley, which is the middle part of the state that grows all our fruits and walnuts, basically, has a very similar issue. And they have over the last several years tried to implement laws governing over extraction of groundwater, and it has been incredibly messy and controversial and a fight the entire way, right? So yeah, that's an issue, right? Like groundwater, and subsidence. So groundwater has been traditionally something that you pump only when you have to, right? If it doesn't rain. So it's like insurance against it not raining. And when the land subsides, you basically are compressing how much water you can actually store in the aquifer. You could like recharge the aquifer, but if the land subsides enough, then the aquifer holds less and less water. So over time, extracting the water, you're getting rid of your drought insurance too, and then it's no good. Yeah. So yeah, I used to do more water rights stuff, water resource stuff, and it is more like the Wild West, right? A more interesting problem, governed by personality and politics.
Has all of this made you more of an optimist
oh, if I were to think about stuff that keeps me up at night, it's not climate change. And I think part of that's because of here you go. Oh, let's say this. I'm also subject to this. Like, there were definitely times in my life where I felt more profoundly worried about climate change, but I'm also not gonna live to see the worst of it. Like, it won't happen, right? And I don't even know if my kids will. Like, we'll see, right? Like, but it is a longer term issue, and I think that does diminish how much it really keeps me awake at night. I'm more worried about other stuff, like AI or bird flu, or it's not like I don't think there are like other threats that are like existential for us, right? But climate change, it's part this, right? It's partly that it does feel kind of far away, even though every once in a while we get a clear sign that it's happening, right? The other thing I'd say is that, yeah, we're making progress, right? It's not perfect, right? But it's not nothing either. Like, we could be in the pink territory and we're solidly in orange, right? When last time I was here, I was 18 years old, right, in Lakeside. We were in red territory then, right? And over the last 22 years, right, collective action by governments, advances in technology, all that stuff has gotten us closer towards something that looks a little more sustainable, at least from the perspective of climate change. Now, I will say that there's lots and lots of evidence suggesting that it gets harder the closer you get to decarbonizing, right? Not easier, because we're doing all the easy stuff first, and then we're gonna get to the parts of that pie that are really difficult to address, right? And, but that's my kid's problem. They'll figure it out.
So to the meat question,
Yeah.
I had a personal encounter with this recently because I had a cholesterol score of 265.
Yes.
And I thought,
Same.
oh, this is interesting. I
Yeah.
can either go on medicine or I can try to fix this myself.
Yeah.
So I became plant-based.
Cool.
And within 3.5 months,
Yeah.
I dropped my cholesterol score by 70 points.
Yeah, exact same thing happened to me.
So
Yeah.
there are a lot of health benefits to that. So
Yeah.
if you say you don't want to stop eating meat, you might want to think about diabetes, you might want to think about heart health, because that's a much healthier way for people to live. And I also have concerns about, are we going to create more impossible meats? That's just more ultra processed,
It
which
is.
has its own set of problems.
You're right.
With all of the additives that the food industry
Yeah.
puts into those, and that also contributes to probably, other health issues.
Yeah.
But I'm also concerned about two other things. One, the CAFOs, animal feedlots in Ohio and the neighboring state that contribute to water issues in Lake Erie. And then I'd also heard about methane deposits in the Antarctic or the Arctic that
Yeah.
are being released. Is that part of the
That's the
game changer?
Was it inevitable? That's on here. Right, so the permafrost. The permafrost thawing is an issue in upper parts of North America and elsewhere. Because underneath the permafrost is like land that's totally frozen, not ice, but like frozen land. Underneath it, we've discovered, is like a sea of methane, which is a really potent greenhouse gas, right? So if that part of land, the upper parts of North America and like Eurasia become warmer and the permafrost melts, then all the methane's gonna escape. So that's definitely an issue. And on the meat question, I'm the same. Like I mostly try to be vegan, and it's for health, right? Because I have high blood sugar genetically and high cholesterol genetically. And so it's either that or probably go on some kind of medicine. And it pisses my wife off, it pisses my kids off, right? But like, I got kind of used to it. Like, it's not that bad. But I agree with you, yeah, the Impossible Burgers I really like, but I kind of treat them like fast food because there's no cholesterol in them, but I don't think they're great for you because they're pumping them full of all sorts of stuff that makes them delicious, right? So once in a while. Plus, I think Burger King cooks them on the same grill as the real meat, and so it's like, oh, that's so good, yeah.
All right, one more question, because I have another program coming.
Okay.
This is a big one.
Okay.
Take as much time as you want, but United Nations forecast for world population, which is what really drives this whole thing. It's about consumerism, it's about the world population expansion,
Yeah.
but they're predicting in about 100 years, roughly, that world population is going to crash.
Yeah.
And that's going to have a much larger impact on this whole equation that we're
Yeah.
talking about.
I agree.
Comment?
I mean, I think, so this is like another example of something that is probably very destabilizing, right? That doesn't have necessarily anything to do with, well, it probably would help with climate change, right? But yeah, countries that lose population don't do well, right, economically. And they face other types of existential risks. But yeah, I think a lot of that has to do with wealth and technology and all sorts of stuff. I'm not as well versed in that. Those longer term forecasts or what their implications are. But yeah, I mean, I think there's a way to solve this even with very large, even growing populations. Right, that's the goal, right, is to not depend on major demographic changes to solve this. But it's interesting. I think, it's going to be one of many societally important challenges we'll have to face, right, over the next several decades. I guess my hope is that it's something that, gets us towards a large L, right? If we fix climate change or solve it, however you want to define that, right? Maybe it's the 1.5 degrees Celsius threshold. It is something that kind of by default requires a certain amount of global coordination, right? And I think it's not just the immediate sort of physical risk of climate change that if we solved it would contribute to a higher L, right? But it's the act of getting lots of countries to work together and coordinating on something that kind of imperils us all. Boy, if we get good at that, then I'm way, way less worried, right? About all sorts of other stuff that we might encounter in the future, right? If we can work together and be a little less zero-sum about everything we do. We'll see. I think it's a challenge, it's daunting. It's also kind of an exciting opportunity to have an existential threat, fix it, and sort of show ourselves that we can do this.
Range of comments. Not by any intention, but the world has, in the past, come to one solution for energy. Everybody's using similar technology.
Yeah.
That gives hope that some of that stuff will continue. Frank talked about population. Europe will be decreasing.
Right.
China will be decreasing. The U.S., big decrease coming. So population will be going up, but not with people that look like anybody in this room.
Right.
And it's there, where the population goes up is the bottom of the economic ladder.
Right.
So if it goes up, or if their living conditions improve, will their population growth decrease? That's what's happened everywhere else.
That's right. Yeah.
So it may not hit that. But let me jump to a different subject. Back when you talked about what do I worry about, I think without even recognizing it, we are still focused on every major pollution problem we've had so far, we've solved. Starting roughly the 1950s,
Yeah.
we cleaned up dirt from power plants. Acid rain, we cleaned it up. We, in fact, made farming more challenging by decreasing acid rain. Nitrous oxides, we've cleaned up. And in each one of these, the rain cleaned the atmosphere, and it was all gone very quickly.
Yeah.
This doesn't behave that way.
Right.
And that's what we have to remember. This is very different than any other problem we've addressed. It takes a very long time to remove CO2 permanently from the environment.
Yeah.
So wherever we stop emitting more carbon than we should, that's the level of CO2 that we're going to be stuck at. Your chart goes out 100 years
Yeah.
because that's as far as we model. But there's another 100 years after that. And if we're still emitting CO2,
Yeah.
we've just changed the rate of increase.
Yeah, I think that realization has motivated a lot of investment in carbon capture, right? So the federal government will now pay you to pull CO2 out of the atmosphere. And it's not that that is trying to motivate any real difference in the climate. They are trying to encourage people to invest money in technologies that make it cheaper and cheaper and more effective to pull CO2 out of the atmosphere, because they know we're going to have to do that. Towards the end of the century, even if we stop emitting CO2, we're going to have to start pulling off. Yeah.
I have a question, whether we will ever get to an affordable, practical means of doing it.
Yeah, that's a healthy skepticism, yeah.
The challenges are huge.
Yeah, I think they're assuming that the profit-making potential will encourage some breakthrough technology. We'll see.
We just don't know yet.
Yeah.
This is one of these, it looks really great, but as you get closer to commercialization, nothing else has ever behaved differently than it gets worse and worse.
Right. Right.
Thank you very much, Jordan. Thank you.
Right. Thanks for all your questions. Oh, good. Good. Yeah. Hey, thanks for all your questions.
Oh, I gotta take this.
Okay, go for it.
But can I get a copy of that tomorrow?
Of course. Yeah.
Yeah, I'm Bill Smith.
Bill, yeah. Nice to
One
meet
of
you.
my lifelong, yeah, most of my career was spent emitting. Now I'm trying to encourage
Cool.
that it's a problem.
Well, thanks for coming. Yeah. Hey, yeah, sure. Thanks.
Is tomorrow continuation, different time?
Tomorrow's going to be a narrower topic, like a more traditional sort of scientific talk on, it's related, but it'll be more in the weeds. Yeah. All right, cool. Yeah. Yeah, I got to go talk to Phil.
Yeah. Where are you staying?
3rd and Jasmine.
3rd and Jasmine.
Yeah, we rented a place.
Oh, you did?
Yeah, because my folks were planning to come up too and stay. And then my dad got sick. He's got a cold, and so they didn't make the trip, which is a bummer. But
But it's part of life, unfortunately. I'm learning more and more, so.
John, I think I'm messing this up. I don't think I successfully turned it off.